Yeah, hello students. Today I am going to start a new topic called sets. Sets. So important part. Actually, this is the first part of calculus. After sets, second part is relation. Next functions. Next limits. Next differentiation. Next application of differentiation. Seventh one, integration and application of integration. This is the order. So this total is belongs to calculus. This is the total part of calculus. So first of all, we need to complete sets, relations, after that functions, limits, differentiation, application of differentiation, integration and application of integration. So one chapter is interlinked with other. Without sets you can't learn the relations. Without relations you can't learn functions. Without functions you can't learn limits. Without limits you can't learn differentiation. Without differentiation no application. Without differentiation you can't learn integration, like that. So first of all you need to complete the first chapter, that is called sets. Okay students, first of all I want to define set. Set is singular, sets is plural. Set means what? Set, definition of set. Actually definition of set is the well-defined collection of distinct object. Well-defined collection of distinct object. Well-defined, that is important, well-defined collection of distinct object. Well-defined and distinct, both are important. So what is the meaning of well-defined collection? I will explain through example. For example, there are two boys A and B. Okay. So I asked A and B, go and collect three natural numbers. A collected as 1, 7, 9. B collected 7, 10, 100. So what A collected? Those three are natural numbers only. What B collected? Those are also three natural numbers only. This is one situation. So next I asked the same students, go and bring good books from your library. So A brought a book A, B, C. B brought the book B, E, F. What happened? What I asked? Go and bring good books from your library. So A brought A, B, C. B brought B, E, F. Here difference is, what is the difference between this example and this example? Here this is not well defined collection, because so with reference to A, B, C are good books. With reference to B, B, E, F are good books. They are different, no? They are different. The good books is different upon the nature of A and B. Okay, that means according to A, B, C are good books. According to B, B, E, F are good books. Only B is common for both. But what happened here? After collecting the what I told to A, go and collect three natural numbers. He collected 1, 7, 9. Without doubt you can say that they are natural numbers. Without doubt you can say that 1 is a natural number. Without doubt you can say that 7 is a natural number. Without doubt you can say 9 is a natural number. Like that B collected 7, 10, 100. Without doubt you can say that 7 is a natural number, 10 is a natural number, 100 is a natural number. How can you say this is good book? How can I say this is good book? With reference to A, book A is good book. With reference to B, E is good book. How universally you can't say that A is a good book and B is good book? That's why this collection is only just collection. This collection is not treated as well-defined collection. So to know its goodness, further information is required. So measurements are required. According to that measurements only you can decide those good books are not. So with reference to A, these three are good books. With reference to B, these three are good books. That's all. That's why collection of good books from your library, just collection, that won't form a set. So collection of first three natural numbers or collection of any three natural numbers, so that will form a set, because those are treated as well-defined collection of distinct objects. Students, listen. After collecting the elements, without doubt you want to say that those elements are belongs to our collection. So these are not belongs to our collection. Our collection with reference to A is good book, no? With reference to me, I can't say that A is a good book. But anyone with reference to A or with reference to B or with reference to anyone, 7 is natural number only. Understood? That's why well-defined collection of distinct object is called a set. So collection of good books, collection of good boys, okay, those are not form a set, they are just collections. Okay, here collection of good books. Okay, So what is here? Collection of first 3 natural numbers, collection of first 7 natural numbers. Like that, these all are form a sets. Okay students, now final conclusion. Set is the well-defined collection of distinct objects. Again I am using the word distinct. For example, one boy collected the natural numbers. For example, I asked one boy collect the 5 natural numbers. One collected 1, 1, 3, 7, 4. So these are natural numbers only, but he repeatedly collected 1 and 1. I can't say that this will form a set of 5 elements. Will form a set of 4 elements only. Okay, that's why set means collection of well-defined distinct objects. Okay, after collecting the elements, they should separated by commas and enclosed by 2 flower brackets. This is a representation of a set. Okay, this is said to be set 1, 7, 9. For example, using these elements, I can make a set 1, 3, 7, 4. Okay, this is another set. Generally, sets are denoted by capital letters. A equal to this, B equal to this. For example, C equal to 1, 7, 1 by root 2. This is one set, this is another set, this is another set. One thing. These are called elements of the set. 1 is element of A, 7 is element of A, 9 is element of A. 1 is element of B. For these two sets, observe 1 is common for both A and B. 3 is element of B, 3 is not element of B. These are called elements or members or points of set A. One thing. Next thing is set, for example, set 1, 7 and set 7, 1 are same. The order of the elements is not important in sets. Important note student, order of the elements is not important. Set 1, 7 or set 7, 1 both are treated as same sets. Okay. So repetition of elements we won't allow. So final conclusion, any collection of well-defined distinct object is called a set. The objects in the set are called members or elements. Okay. Okay, Shun. Just now I explained what the definition of set through examples. So actually, after collecting the elements, they should separated by commas, okay, and enclosed by 2 flower brackets. This is called a set. For example, set generally denoted by capital letters. I can say set A is equal to A, B, C, D. Here A is said to be the member of set A, B is another member, C is another member, D is another member, or elements or points. So A is a member of A, that is mathematical you can say that A is belongs to set A. The element A is a part of A. A is belongs to B. Correct? A is belongs to A. Small e belongs to A. Small c belongs to A. Small d belongs to A. Small e doesn't belongs to A. So because E is not element of the set A, you can write it as E doesn't belongs to A, does not belongs to A, you can read as. Okay. Next one is representation of sets. Representation. Usually sets are represented in following 2 ways, roster form or table form. Second one is set builder form or rule form. I will explain through examples. Important representation. Generally we are using 2 types. One is roster form, another one is set builder form. Roster form is also called tabular form. Set builder form also called rule form. Okay. So roster form, what is the meant by roster form? I will explain through example now. Observe, A is the set of first 5 natural numbers. So this is now A is the set of first 5 natural numbers. Okay, how to write this in roster form and set builder form? Roster form means what? Means just list. We need to list all the elements. We need to list all the elements. That's why sometimes the roster form is called list form. Roster form, first one, roster form. I want to write this set in roster form. A equal to, write flower brackets. Write all the elements which are belongs to that set. first 5 natural numbers, no? 1, comma, 2, comma, 3, comma, 4, comma, 5. This is roster form of this set. Okay. One more example I will take. First of all, one more example. Students, listen now. One more example. For example, yeah, B is the set of first 100 natural numbers. How to write into roster form? B equal to set bracket. We want to write all 100 natural numbers. No, we can't write all 100 natural in our book. So how we will write 1, comma, 2, comma, 3, comma, 3 dots, comma, 100. This is called roster form. Roster form or sometimes called list form. Simply we list all the elements. This is one thing. Same set is given. How to write in set builder form? What is the set builder form? I will explain. And set builder form also sometimes called ruled form. Rule form. So to write set builder form, first of all, for same example, first of all you write A and flower brackets. First of all you will write a variable X. Any variable X, Y, Z, small r, small, anything you can write. X should write first. After that, such that symbol, such that, and close the bracket. So this is a set builder form. So in this space you want to write a rule satisfied by X. In this space you want to write rule satisfied by X. What is X here? X is a natural number, that too less than or equal to 5. So X is a natural number which is lesser than or equal to 5. Means X may be 1, 2, 3, 4, 5. So through rule you want to write here. Now I will write X lesser than or equal to 5 where X belongs to N. This is called rule form. This is called set builder form. Set builder form is important for us. So using the example, I explain what is roster form and what is set builder form. In roster form, what should do? Simply we list all the elements. In a set builder form or rule form, what should do, Nana? You need to start the set with a variable and you read as such that X such that X lesser than or equal to 5, comma, X belongs to N. So here you need to write a rule satisfied by this X. Okay. So important thing is, why you want to write a set in set builder form, you can't write in unique way. Several ways you can write. For example, same thing I can write another way also. See, X such that I can write X lesser than 6 and X belongs to natural number. Less than, here lesser than or equal to 5, here I wrote less than 6. Less than 6, 1 to 5 natural number, no, here clearly mentioned. That's why A equal to X such that X less than 6 and X belongs to N. This is the set builder form of this example. Set builder form is very important than roster form. For example, here another set is given. B is a set of first 100 natural numbers. So B can be written as 1, 2, 3, dot 100. This is called roster form. Same thing you want to write in a set builder form. Okay, B equal to some any variable Y such that. Sometimes you can use this symbol also for such that. Y such that. So what is Y? Y lesser than or equal to 100. If you close the bracket, this becomes wrong, Nana. Y lesser than or equal to 100. What is Y should mention? No. Y is real number or complex number? What? Y only natural number. No. That should also mention. Y belongs to capital N. So this is the set builder form of this set. Okay. Set builder form is important than roster form. Okay, students. So generally we have two ways to represent a set. One is roster form, another one is set builder form. Okay. Example. A equal to 1, 1 by 2, 1 by 3, so on 1 by 10. This is roster form of a set. We want to write it into set builder form. Set builder form to roster easy, but roster to set builder form difficult. A roster form is given, you want to write it to set builder form. See how I am writing. Observe all of you. A is nothing but X. Such what is X, Nana? X equal to some 1 by K. What is K? K is a natural number lesser than or equal to 10 and K belongs to natural number. Okay, what I wrote now, observe here, this is set builder form, important form. A equal to X such that x equal 1 by k, k lesser than or equal to 10, k belongs to n. Observe, no, take k values from 1 to 10, what you will get? That only, no, a only. So this is the set-builder form of this set. So once again I am saying, you don't think that you can write only unique way, you can write several ways. Same thing I will write, see, a equal to 1 by y such that y lesser than or equal to 10 and y is a natural number. So this is also set-builder form only. Okay. One more example. A equal to 1 comma 2 comma 3 comma 6 comma 12 given. We want to identify what rule followed by all these points. 1, 2, 3, 6, 12. So you want to set builder form. I am writing, observe here, x such that x is a factor of 12. Observe, satisfying, no? X is a factor of 12. These are all factors of 12 only. Okay, you want to write 4 also. I forgot to write 4 also. Okay, 1, 2, 3, 4, 6, 12 given. You want to write into set builder form. What I can write? X such that x is a factor of 12. Means here variable should write, na, such that after that we want to write a rule satisfied by that variable. Okay. Next, a equal to 2 given. What I can write in roster form, set builder form? Several ways you can write. One of the ways, x such that x is even prime. X is an even prime. Okay. So set builder form is important than roster form, students. So roster to set builder form conversion is difficult. Set builder from roster is easy one. So finalizing, set definition. Any collection of well-defined distinct objects is called a set. The objects in the set are called members or elements. Belongs to, does not belong to symbol also explained. Representation of a set. Usually sets are represented in following 2 ways: roster form or tabular form, set builder form or rule form. Okay. Next, roster form. In this form we list all the members of the set within braces, with brackets, and separated by the comma, just now explained. Okay. Next, here about set builder form. In this form you write a variable, say x, representing any number of the set followed by a property satisfied by each member of the set. This also I explained. Okay, Nana. After this, types of sets concept. Types of sets. Types of sets next. This is very, very important. Types of sets. One by one I will explain. First one is empty set, empty set, or sometimes called null set or void set. Void set, empty set, null set, all are give same meaning, Nana. So I want define a set without any element. A set without any element is called empty set. I will write examples. A given. Just to do brackets, nothing is there inside. So this is one example for null set. A is a null set. Empty set means a set without any element. Okay, sometimes you want to write example by using set builder form, that is important, Nana. Observe, A equal to, observe, Nana, x such that x square plus 1 equal to 0 and x belongs to real number. So this is example for empty set because there is no real which gives x square plus 1 equal to 0. So this is one of the example for null set, empty set, void set. One more example I will write, Nana. B equal to x such that x is a even prime, is an even prime greater than 2. So this is also another example for empty set. There is no even prime greater than 2. No? We have only one even prime, that is 2 only. So this is also another example for empty set. Okay. Yeah, some examples are given, Nana. Next. Yeah, non-empty set. The set which is not empty is called non-empty set. Means this set containing at least one element. The set containing at least one element. Such set is called non-empty set. Okay. Next, singleton set. Singleton set, a set containing only one element. A set containing only one element is called singleton set. Singleton set. Singleton set. A set containing only one element. Several examples I can write. A equal to 3. A equal to, I will write in set builder form, x such that x is an even prime. So this is a singleton set only. This is also singleton set only. Like that you can give infinitely many examples. But important note, most of the students will confuse. So this is empty set only. So one more emptiness is there inside. This is taken as singleton set. This is taken as singleton set, not a empty set. I forgot to explain one thing about empty set. Actually, empty set denoted by this symbol, pi. This symbol A equal to pi means this is empty set. Okay. So actually, this can be written as this. So this is singleton set, not empty set. Just like a empty box is there, inside another empty box is there. You can say that the bigger empty one is bigger box is not said to be empty box, like that. So this is important note. This is singleton set, is not treated as a empty set. It is not treated as an empty set. Next, important finite set and infinite sets. Finite sets and infinite sets. I will explain. Finite set. A set containing finite number of elements. A set containing finite number of elements means that if a set is given, so if a set is given, I want count the how many elements are in that set. I started my counting 1, 2, 3, 4. If my counting surely will end, then I can say that that is finite set. Otherwise, this set to be infinite set. Here 1, 2, 7, I can count 1, 2, 3, 4 ended. So this is finite set. A set containing finite number of elements is called finite set. A set containing infinite number of elements is called infinite set. So finite set is this. Example for infinite set, n is a set of natural numbers which is said to be infinite set. Z infinite set. R infinite set. These all are infinite sets. So I want give example for finite set and infinite set. A equal, for example, f equal to x such that x is a factor of 12. It is a finite set. For another example, some q equal to x such that x is a multiple of 12. This is infinite set, no? Multiple of 12 are infinite. So it is multiple of 12 means infinite set. One more example I want to take, r equal to x such that okay, 2 less than x less than 3 comma x belongs to r. So this is also infinite set only, because x is a real number in between 2 to 3. How many real numbers are there in between 2 to 3? There are infinitely many real numbers are there between 2 to 3. See number line, this is 2, here 3. So many dots will be in between 2 and 3. Infinitely many dots. 2.1, 2.1, 2.001, 2.001, 2.001, like that. So many real numbers exist between 2 and 3. That's why this is also one of the example for infinite set. Okay, important note is, last one, important note is, so empty set is also treated as a finite set. That is important. Empty set also treated as a finite set. So this is types of sets are going on. Finite, infinite set completed. Next, cardinal number of a finite set. Cardinal number of a finite set. Cardinal number is defined only for finite set. Cardinal number of a finite. For example, set A is given 1 comma 2 comma b comma k. Okay. Now cardinal number of A denoted by n of A. N of A is a whole number. That whole number represents how many elements are there in the set A. So that is called its cardinal number. I can say that here for this example, n of A equal to 1, 2, 3, 4. I can say 4. 4 is called cardinal number of this set. Understood? So the number of distinct elements in a finite set A is called the cardinal number of the set A and is denoted by n of A. So cardinal number is defined only for finite set. So I want to write example, A equal to X such that X is a letter of word school. What is N of A? Some students will make mistakes. They will write 1, 2, 3, 4, 5, 6. But actual N of A is 5 only. 0 won't repeat. You write if it in a roster form. How can you write in roster form? A equal to S comma C comma H comma O comma L. You can't write 2 times 2. No? Distinct elements. That's why 1, 2, 3, 4, only 5 elements. That's why I can say the N of A equal to 5. So this is about cardinal number. So one more important thing is N of pi is what? That is 0. Cardinal number of empty set is 0. Cardinal number for infinite set not defined. Cardinal number is only for finite sets. Okay students, next equal sets and equivalent sets. Equal sets and equivalent sets. Through example I will explain. Equal sets and equivalent sets. 2 sets are given, A and B. These 2 sets are said to be equal sets if every element of A is in B and every element of B is in A. Then they are said to be equal sets. For example, A is given as 1, 2, 3. B is given as 3, 2, 1. Observe Nana. Every element of A is in B, no? 1 is there, 2 is there, 3 is there, and every element of B should be in A. 3 is there, 2 is there, 1 is there. Such situation, those 2 sets are said to be equal sets and they are denoted by this symbol A equal to B, equal sets. Okay, A and B are 2 sets are said to be equal if every element of A is in B and every element of B is in A. Okay, for example, A is given as 1, 2, 3. B is given as 2, 1, 3, 4. Every element of A is in B only, but every element of B is not in A, no, 4 is not there. That's why A and B are not equal sets. I can say A is not equal to B. So this is the definition of equality of 2 sets important. After that, equivalent sets. Equivalent sets. What is the definition of equivalent sets? I will explain through example. A equal to A comma B comma C. Okay, Rana? B equal to 1, 2, some C. Okay, here A and B are not equal sets, no? A and B are not equal sets, but they are said to be equivalent sets. If cardinal numbers are equal, if 2 sets are given, 2 finite sets are given, if their cardinal numbers are equal, then you can say that they are equivalent sets. Say N of A is 3, N of B also 3 here. N of A equal to N of B. Then such situation, those 2 sets are said to be equivalent sets. Okay. So important thing is, in previous example, what I taken here, these 2 are equal sets as well as equivalent sets. Means what is the meaning of that? If 2 sets are equal, automatically they will become equivalent. If 2 sets are equivalent, they need not become equal sets. Okay, students. Yeah. Next concept, important concept, subset, very important. Now I will take time to explain this. Very important. Subset. So listen all of you. Subset. See here, A is a set, B another set. Every element of A is in B. Every element of A is in B. Just that's all. No need to check every element of B is in A or not. That is not important. Every element of A is in B. Then A is said to be subset of B. We will write this symbol for subset. Every element of A is in B. Directly you can say that A is subset of B. One thing. Next thing. Every element of A is in B. And at least one element is there in B which is not in A. Such situation, A is called a proper subset of B. A proper subset of B. Identify the difference between these two, Nana. Just every element of A is in B. Then A is said to be subset of B. Here what happened? Every element of is in B and at least one element is there in B which is not in A. Such situation, A is said to be a proper subset of B. Okay. So, A is subset to B and A is proper subset to B. For example, A is given as 1, 2, 3. B is given as 1, 2, 3, 4, 5. See, every element of A is in B only. 1 is there, 2 is there, 3 is there. So, you can say that A is subset of B, A is subset of B. Actually, you need to write proper subset because every element of A in B and some more elements are there in B which are not in A. Actually, you need to write A is a proper subset of B. But nowadays, A is also treated as subset of B. You can while reading, you can say that A is subset of B. Actually, A is said to be proper subset of B. Okay. Now, according to our knowledge, presented day concepts, I can say that A is subset of B. Every proper subset is treated as a subset. Okay. Every element of A is in B. That's why I can say that A is subset to B. I can write A is subset to B. Actually, A is proper subset of B. Actually, you want to write like this symbol. But without knowing the element, just every element of A is in B, then you can say that A may be equal to B. That is not big problem. That's why you can say that A is a subset to B. This subset symbol is for proper subset. Once again, listen students. P and Q are two sets are given. Every element of P in Q, no need to cross check. Just I can say that A is subset to B. But in elements wise given, P is given, Q is given. Here directly you can say that P is proper subset of Q or just subset. You can directly can say. So 1, 2 is given. Here 1, 2, 3 given. Directly I can say P is a proper subset of Q. Understood? Here also 1, 2 only given. Every element of P is in Q and every element of P in Q, actually these two are equal sets. So what I can say in the meaning of this, P is a subset of Q means it may be equal, The meaning is it may be equal. So P proper subset means never, P never equal to Q. So P subset to R means P may be equal to R. So this is the concept of subset and proper subset important. Nowadays, proper subsets also treated as subset, that is important. Okay, once again listen. Yeah, A and B are two sets. Every element of A is in B, then A is said to be subset of B. Or B is called superset of A. P is called superset of A. A is subset to B, then B is called superset of A. One thing. Next. Nowadays, proper subsets also treated as subsets only. For example, A given as 1, 2. Okay. B given as 1, 2, 3. Generally, you want to say that A is a proper subset of B. While counting how many subsets are there means this proper subset also treated as subset only. Okay. That is one thing. Important note. Empty set treated as subset to every set. Empty set is treated as subset to every set. Here observe, see here I mentioned clearly. Empty set is subset of every set. One thing. Second one is every set is subset to itself. Every set is subset to itself. Observe here. Every set is subset to itself. So these two are very important. Note nana. For example, A is given as 1, 2, 3. Write all possible subsets. Subsets proper also should write. Those also treated as subsets only. So write all possible subsets. Just now explain. No? So pi is a subset of A. Counting. Okay. Set 1, 2 also subset of A. Because empty set is subset to every set. Every set is subset itself. We got two subsets for A. More exist. By using 1, 2, we can create none. See set 1. Actually, set 1 is proper subset to A only. Understood? So I can call it is a subset also. So set 1, set 2. More subset won't exist. How many? 1, 2, 3, 4. A set given as 1, 2. Using those two elements, you can create 4 subsets. 4 subsets. A set having 2 elements, you are getting 4 subsets. So one more example I want to take. Yeah, A is given as 1, 2, 3. 3 elements are there. Now I want to count how many subsets exist for set A. Empty set is subset to every set. Every set is subset itself. So 2. By using these elements, I can create so many proper subsets. Set 1, set 2, singleton sets first of all. Set 3, set 1, 2, set 1, 3. Okay. So what happened? This is proper subset to A only. I can call subset. This is subset. This is subset. This is subset. This is subset. So how many? 1, 2, 1, 3 and 2, 3. 2, 3. So count the number of subsets possible. 1, 2, 3, 4, 5, 6, 7, 8. Means if you set containing 3 elements, you are getting 8 subsets. Okay. If a set containing n elements, then that set will containing 2 power n subsets. 2 power n subsets. Observe, huh? 2, no? 2 power 2, 4. 3 elements are there, no? 2 power 3, 8. That's why if a set containing n elements, that set will containing 2 power n subsets. Sometimes they will ask how many proper subsets. Except this, all are treated as proper subsets only here. Actual proper subset. 5 is actually proper subset of A. Set 1 is actually proper subset of A. Except this, all are proper subset. That's why if a set containing n elements, that set containing 2 power n minus 1 proper subsets. Okay, students. So this is the concept of set, subset and superset. Important. Symbols important. In general, the symbol is for subset. The symbol is for proper subset. Okay. Okay, so next concept na power set. A set A given, power set denoted by the symbol P of A. P of A set of subsets of A. Set of subsets of set A is called its power set. For example, A is given as 1, 2. What is P of A means? You want to write all the subsets of A, the 2 in the set form. Set of subsets of A is called power set. First of all, I want to write what are the subsets. Pi is subset, 1, 2 is subset, set 1 is subset, set 2 is subset. How many? 4 are there. So those are enclosed by 2 flower bracket. So the new set is called power set. What is that? 1, 2. So this is called power set and set of subsets. Okay. Example students, important this one. If set A have 3 elements, then number of subsets for set P of A. Now you want to find number of subsets of P of A. First of all, you want to find how many elements exist in P of A. A having 3 elements means P of A will have 8 elements, no? 8 elements. N of P of A becomes 8. Number of subsets of A, no? 8 elements. So what asking? How many subsets exist for P of A? P of A having 8 elements, then P of A will have 2 power 8 subsets. Yeah, I want to generalize that. Yeah. If N of A equal to K, then number of subsets of A equal to 2 power K. Okay. Next, number of elements in power set. number of elements in P of A, or I can say n of P of A, I can say. Again 2 power k only, no? N of A is k elements, number of subsets of A is 2 power k. Power set means set of subsets only, no? So n of P of k means 2 power k. Now number of subsets of P of k. Number of subsets of P of k, P of A is 2 power k. Okay.